अस्सलामुअलैकुम dear students. फर्स्ट ईयर की केमिस्ट्री के चैप्टर नंबर 7 केमिकल इक्विलिब्रियम से नेक्स्ट टॉपिक है सॉल्युबिलिटी प्रोडक्ट. ठीक है, सॉल्युबिलिटी प्रोडक्ट इन अ कांस्टेंट ऑफ सॉल्युबिलिटी प्रोडक्ट एक्सप्रेशन जो है हम उसको किस तरह जो है रिप्रेजेंट कर सकते हैं. So these solubility products that will be explained in terms of constant of solubility product. Terms of constant of the solubility product, which is represented as KSP, a constant of the solubility product. Okay, first of all we have to learn some terms in that solubility product or a constant of solubility product. Okay, the point number first, that the constant of solubility product, this one is used for sparingly soluble salts. Okay dear students, so what is sparingly soluble salt? Sparing soluble salt is that one, the salt which dissociates partially, not 100%. And that salt is known as a sparingly soluble salt. Actually, by this solubility product or a constant of solubility product, we actually find out the strength of that salt to be dissociated in water up to how much. Either it dissociate up to 10% or 20% or 30%. We find out this from the solubility product. We also find some other terms from that of the solubility product or a constant of solubility product. Like we find precipitation, that which salt will be precipitate quick and which salt will be precipitate slowly. So we also find out this from the KSP. Okay, first of all, we have to define this KSP. So first of all, we have to make a definition for this constant of solubility product. And the definition is, definition of the solubility product, and that is log that this constant of solubility product, that is equal to, this is the product of molar concentration of ions of sparingly soluble salt raised to some exponent, then that product, that multiply form of the molar concentration of ion of a sparingly soluble salt raised to some power. What is the exponent? Exponent is basically in the balanced chemical equation, the number of moles of ion, or in the balanced chemical equation, when we put that as a power of the concentration terms of the ions of a sparingly soluble salt, that is actually known as the exponent. I will explain this one by an example. Now we have to pick an example. Left for example, if I say that there is a salt, a sparingly soluble salt, silver chloride we take, and we dissolve that salt in water. This is in solid form. It's not going to happen to be dissolved 100%. So it forms silver ion aqueous, and chloride ion aqueous, but not 100% to be dissolved. Why I use the term aqueous? Because the water will surround these ions. So it shows a reversible term, reversible. There is reversibility present in this dissolution of silver chloride. Because it's not dissolved to be 100%. This is a sparingly soluble salt. Look dear student, if I want to write the Kc for this expression, You all know about how to write Kc for reversible reaction, and remember that we studied this point. that in the Kc expression only aqueous form, solution form will be expressed, or either you express the gaseous reactants and product but not the solid one, this one. So look, let's we move to the constant of solubility product. We check out the solubility of a salt sparingly soluble salt. So the Kc of the equation becomes this: concentration of silver ion, as its number of moles is 1 here, so there is no need to write 1 as a power, as an exponent, and the concentration of chloride ion. But if I write here the concentration of silver chloride, molar concentration, remember dear student, this concentration is taken as constant, because there is no net change occur in the concentration of solid and true liquids. So what we have to do, we have to write this constant with the Kc to get another constant. And that is concentration of silver ion and concentration of chloride ion. So these two constants get a rise a third constant, and that is equal to Ksp, a constant for the solubility product of the silver chloride here in this equation. So that's equal to the concentration of ion. It's the product of the molar concentration of ions. This is the product of the molar concentration of ion of a sparingly soluble salt. That is actually known as Ksp. Is it clear? That is, Ksp is the concentration, molar concentration of ions of a sparingly soluble salt. For example, we have to take another example. Let's pick another example, dear students. Let's pick another example. Look. For example, if we have a question like that, for example, there is a question that write Ksp expression. For example, for a salt, calcium fluoride. For example, we have to write a Kc expression for calcium fluoride. So how we write that one? We'll write this one is that calcium fluoride in dissociate in the aqueous medium, it form calcium ion. Look here, calcium ion, because oxidation state of calcium here is +2. This is form fluoride ion, but we want to write a balance equation. So we will write here 2 moles of the fluoride ion. Remember that we will represent a balanced chemical equation. So if I write the Ksp expression for this one, for sparingly soluble salt calcium fluoride, in the Ksp here, that's equal to concentration of calcium ion, okay, concentration of fluoride ion, but it has raised to power 2 as according to its definition. According to its definition, that's the product molar concentration of ions of a sparingly soluble salt raised to some exponent. What is the exponent? Now look here, this is the exponent. The number of moles of ion in the balanced chemical equation, that number of moles, that stoichiometric coefficient will get raised as exponent. So this one represent the Ksp expression of calcium fluoride. Okay, dear students? Okay, we have to take a question from this one, a numerical question. Okay. Okay, dear students, let's take a numerical question. For example, we have a question. The question is that if the solubility of silver chloride is 10 raised to power -2, okay, mole per d cube or molar, then KSP will be. Okay, I will write here a question mark. What will be the KSP? If you have the solubility of a sparingly soluble salt, so how you have to solve this numerical? Okay, look here. If you answer this question, then we know that here in this question, the solubility of silver chloride is given, and that is 2 10 raised to power minus 2 mole. The solubility is given. And what they demand in the question, they demand to find out the KSP. So I will write here a question mark, that we have to find this one, that what is the KSP. So how you have to solve this one? Remember students, first of all, you have to write the equation for that sparingly soluble salt. Okay, silver ion concentration and chloride's ion concentration. Okay, first of all, to find the KSP, you need the molar concentration of these two ions, because without knowing the concentration of these ions, you can't find out the KSP. Because KSP is the constant of solubility product at the equilibrium state. So look here, if the solubility of this silver chloride is 2 10 raised to power minus 2. This silver ion is formed to 1:1 of that silver chloride. So you will also write as it is. अब आप कैसे करोगे? इधर जितने नंबर ऑफ मोल्स है, लाइक ये 1 मोल सिल्वर क्लोराइड की कंसंट्रेशन, तो सिल्वर आयन कितने टाइम्स बनेंगे? ऑलरेडी 1 मोल्स टाइम बनेंगे, 1 टाइम बनेंगे, बिकॉज यहाँ पे इसके नंबर ऑफ मोल्स 1 है. So we get 2 10 raised to power minus 2 molar concentration of silver ion, and as that of chloride ion, same 2 10 raised to power minus 2. Once you find the concentration of ions here, after that you have to write the KSP expression, which is equal to silver ion concentration and multiply chloride ion concentration. So अब आप क्या कर लोगे? आप इसमें पुट कर लोगे, वैल्यूज पुट कर लोगे. तो लो, सिल्वर आयन कंसंट्रेशन है 2 10 raised to power minus 2, and क्लोराइड आयन की कंसंट्रेशन है 2 10 raised to power minus 2. So what we get in the KSP expression, or the KSP of silver chloride is 2 to 2 multiplied becomes 4, and the multiplication of the power here, the powers to be added, so it becomes as 4 10 raised to power minus 4. So that is the KSP of the silver chloride, has a solubility of 2 10 raised to power minus 2. Is it clear? Okay, for example, let's pick another question here. Let for example, I will write another question. The second question is, let for example, state that F solubility of silver chloride is S. S is a solubility. This is a general term. This is a general question. Is S. Then KSPS. I will write this in MCQ because definitely in the board paper you will feel such type of questions. Let for example, the KSP of this one will be equal to S. Is it clear? Okay, the second option I add here, that KSP is equal to S square. Okay, a third option I add here, that KSP is equal to S power 3. Or a fourth term represent here, that KSP for this one is equal to, let for example, the square root of S. So how you find out the correct option in that question? Okay, again you have to follow the method. आपने method को follow करना है. You have to write the silver chloride, write the silver ion concentration in it, chloride ion concentration. ठीक है dear students. Okay, log if its solubility is S, like from this one, if there is n value, then what will be the concentration of ion? Then the concentration of ion is S, or chloride is also S. No, the K is P well becomes A's, silver ion concentration and chloride ion concentration. So what we get? We get that KSP is equal to concentration of silver ion is S and concentration of chloride ion is also S. So KSP will be equal to S square. So what we have to select here? We select here the option of D, that KSP is equal to S square. S square. Okay? Okay, let's take the next term in the solubility product. The constant of the solubility product. Okay. Let, for example, if you find out the nature of the solution, either the solution is saturated, either the solution is supersaturated, either the solution is unsaturated. So how you have to find out that? Okay. For that one, we need concept of ionic product. Okay, what is an ionic product? Ionic product is basically, this is molar concentration of ions of a salt at any point, either at the initial state or either at the final state. While KSP is molar concentration of ions at equilibrium only. At equilibrium. While ionic product, that's the molar concentration of ions of a sparingly soluble salt at any point, at any position. Okay, let for example, we find this ionic product, which is also represented by as del N. Also, we find out that del N for a process for a sparingly soluble salt, that's equal to KSP. पॉइंट ये है कि देखिए हमने एक साल्ट ऐड किया, ठीक है, एक्वस मीडियम में. हमें पहले से ये जो है क्लियर था कि साल्ट की जो सॉल्युबिलिटी है, इसकी जो केएसपी है, लेट्स सपोज रूम टेम्परेचर पे उसकी एक वैल्यू है. लेट फॉर एग्जांपल मैंने ये ऑब्जर्व की कि उसकी वैल्यू 110⁻⁻² है. लेट एज्यूम करते हैं हमने डेल एन फाइंड किया और हमने ये ऑब्जर्व किया कि उसी साल्ट के लिए डेल एन जो आयनिक प्रोडक्ट है, दैट्स आल्सो इक्वल टू 110⁻². इसका मतलब ये है कि दैट सॉल्वेंट इज नॉट फर्दर capable to dissolve more solutes. No, such type of solutions where the KSP and ionic products are equal to one another, such type of solutions, they are known as the saturated solutions. Okay, I repeat students, what is a saturated solution? Saturated solution वो होता है जिसमें एक सॉल्वेंट केपेबल फर्दर नहीं होता कि वो और सॉल्यूट को डिसॉल्व कर सके. अगर टेम्परेचर हम फिक्स रखते हैं, कांस्टेंट रखते हैं, वो मैक्सिमम लेवल तक, अपनी कैपेबिलिटी के लेवल तक वो सॉल्यूट को डिसॉल्व कर चुका होता है, तो फर्दर सॉल्यूट उसमें क्या होते हैं, डिसॉल्व नहीं होते. सच टाइप ऑफ सॉल्यूशंस आर नोन एज सैचुरेटेड सॉल्यूशन. लेट फॉर एग्जांपल we add solute in a solvent, let's suppose in the water, and we observe that the KSP is greater from that of ionic product. If I represent here this one, that if ionic product is less from the KSP, it means that the molar concentration of ions is no less from that of the KSP. As if you see the previous lecture where we study the QC and KC for the equilibrium processes, and there is the same idea like that of the QC and KC. If this del N is less from that of KSP, then it means that the solutes are too little in the solvent. The solvent is further more capable to dissolve the solute. So here, such type of solutions are known as unsaturated solutions. Unsaturated solutions. And there is a third one, F del N is greater from KSP. Ionic product, molar concentration of ion at any point, not at equilibrium. Let's find out to be greater from the KSP. Then remember that such solutions are known as supersaturated solutions. What are supersaturated solution? Those type of solution where a solvent dissolve more and more solutes. But once we raise the temperature for that solvent to dissolve more and more solute. So from the ionic product, we also find out whether the solution is saturated or unsaturated or it's supersaturated. Okay, dear students? Okay. Let's make some few points for the question point of views, for the board question point of views. Some questions related to the solubility product. Okay. Remember, dear students, that if there is a question raised for the precipitation, a few salts, KSP is given, and that says that which salt is easily to be precipitated. Remember that KSP of salts and precipitation is inversely related to each other. What it means, what this hint means for you people to take. And let, for example, there are two salts. I will explain this one like that. There are two salts, sparingly soluble salt. Salt A has KSP value, that is 110 raised to the power minus 2. And there is a salt B which has a KSP value of 110 raised to the power minus 4. And that states that which salt will be easily to precipitate. So the point is, the KSP and precipitation are inversely related to one another. The salt which has a less KSP value will be easily precipitated. So I can write that B is easily precipitated. Then A. This is one idea. You must take this concept. Okay. The second one, dear students, the second concept we pick from that of the KSP. You can also find out the strength of a sparingly soluble salt as an electrolyte on a condition, on room condition. You pick this point is that KSP is also directly related to the electrolyte nature of sparingly soluble salt. Okay, what this relation means? A salt with more KSP value means that salt is much more to be dissolved in the aqueous medium. So we can also say that its electrolyte strength is more from the other. This is a comparison between different salts, sparingly soluble salt. Any salt which has a more KSP value, remember that then its electrolyte nature will be more. There is a direct relation. To the precipitation, KSP is less, then precipitation will occur more. And if KSP is more, then the soluble salt or the salt nature as an electrolyte will be more. What? Okay. If someone of you is not familiar with the word electrolyte, remember that electrolyte is that species which form ions in the aqueous medium, and that is known as electrolyte. So dear students, that's all about the solubility product and ionic product of ions, and then the nature of the solution. We will also study a few questions from that of the solubility product. So hope so you all make the points from that of the solubility product. Okay, Allah Hafiz.